Hey everyone, this is part 2 of the Reaction Stoichiometry homework series. We're just continuing on with other representative samples from this homework assignment. In this next problem, given the following equation, we have nitrogen gas plus 3 hydrogen gas yields 2 ammonia gas. NH3 is the common name for ammonia. Not all of the pieces of information given to you in these homework problems is going to be necessary for you to complete the question. Certainly, a chemist would find it very helpful to know that a substance is a gas, liquid, or solid, but when it comes to measuring the quantities used and calculating how much can be produced or required, etc., the state of matter is kind of a red herring. It's extraneous information. What we do care very much about, though, are the chemical identities and the coefficients in front. That's going to tell us the mole ratio we are going to use when solving this problem. So let's get into it. I have 38.5 grams of N2. Most of the time, you're going to be given a single value in these problems, and that's going to be your starting point. So I'm going to write down my 38.5 grams of N2. Ooh, that 2 was a little bit rough. Now, when it comes to setting up these problems, let's see, there we go. When it comes to setting up these problems, we want to include both the unit and the chemical identity. Those are both essential pieces of information that we're going to be canceling as we go through this question. As always, in order to convert between different substances, we need to go to moles first. If you're ever stuck on an exam question, just go to moles. To get to moles from grams, we need the value known as molar mass. It's right there in the name, molar, because of moles, mass, the grams. To find the molar mass of N2, I'm going to take a look at my periodic table. And there we have it. Nitrogen is 14.007. A very common mistake I see when working with pure elements is that people assume, oh, so nitrogen is 14.007 grams per mole. I'm done. But actually, this is just the molar mass for a single nitrogen atom. In order to figure out the molar mass for the entire molecule, we need to multiply this by the number of atoms present, which is, of course, 2. And so we're going to be using 28.014, and I'll probably round that to 28.01 because I'm a little bit lazy. Okay, so we're going to multiply this value by 1 mole on the top and 28 28.01 grams on the bottom. The reason I want it like this is because I need my grams to cancel. You always want to be canceling one unit every step of the way. I don't recommend solving here. I don't recommend doing the math until you have the whole thing set up. This is a good way to check your work as you go through. Just make sure you're canceling one of the units every time. Now, I have moles of nitrogen gas because I haven't crossed out the N2, and I have my moles here. And so I need to find something that's going to be able to convert nitrogen into some other element or compound. Here, it looks like I'm using hydrogen. And so the mole ratio between nitrogen and hydrogen is as simple as their coefficients. We have 3 hydrogens for every 1 nitrogen. The 1 is never shown. It is implied that you have exactly one of those unless some other value is given. So I'm going to put the 3H2 up there and 1 N2 on the bottom. So my nitrogen cancels. And now I have moles of hydrogen. In order to get to grams of H2, I need to figure out the molar mass for hydrogen. Hydrogen from our periodic table is 1.008 grams per 1 mole. This was for nitrogen. This is for hydrogen. And because I have two of those, I'll multiply this value by 2, and that's going to give me 2.016 grams per mole for the molar mass of H2. Now, I need to think hard about where I want my units to cancel here. I've got moles on top over there, and I want grams as part of my answer. So I'm going to put the 2.016 grams on top, and I'll have the 1 mole on the bottom. Moles cancels with moles, and when I go through and solve here, that should give me the answer. So we'll take 38.5 divided by 28.01 times 3 times 2.016. And I find 8.313 grams of H2. It's a good idea to get in the habit of including that unit and chemical identity at the end, even if you don't put it into the exam and the homework system. It's just going to help you to check your work. When you're going back and looking at your notes, it'll allow you to figure out what you were doing when you were trying to solve these problems. I think it's a good habit to get into. Anytime I solve a question like this, I like to do what I call a reality check. I want to think hard about what's happening here and decide, does it make sense with how I understand the world to work? Chemistry is a real phenomenon. It happens. It's around us all over the place, happening every day, and you can use that understanding you have of the world to decide, does this value make sense? So we're starting with 38.5 grams of nitrogen, and we need to react it with some quantity of hydrogen gas to make a balanced chemical reaction occur, producing those ammonia molecules. Now, it looks like we need way less hydrogen than nitrogen in order to make this reaction work, but I think that's okay because hydrogen weighs significantly less than the nitrogen does. Even though we need 3 times as many hydrogen molecules, I think that this is still a reasonable value. If you had a value that was significantly larger than the amount of nitrogen used, well, that wouldn't really make sense because of the weight difference between the two. Also, if you had anything like a negative value here, that would definitely be incorrect. There is no such thing as a negative quantity of mass in chemistry. All right. I'm just going to check to make sure I did this right, because even as a chemistry professor, I make mistakes. Cool. All right, moving on. The next one I picked up for us to do is this one right here. We're looking for how many grams of water is produced if that many grams of nitric oxide are produced. Where'd you go? Is it this one? It is this one. Huh. This was the one I answered incorrectly yesterday, thinking it was problem 1. Okay. So, given this equation, how many grams of water is produced if 89.10 grams of nitrogen monoxide is produced? Don't worry too much about the required versus produced or necessary or yield. All of those things are not helpful in figuring out how to set up the problem. You're just trying to convert one substance into the other substance using moles as the intermediary. So, the value we are given is 89.10 grams of NO. I'm going to multiply this by its molar mass in order to make grams cancel. In order to find the molar mass of this, I need to find the mass of nitrogen, which is 14.01. And for the oxygen, it's roughly 16.00. Depends how many 9s you feel like including there. And so because there's just one of each of those, I'll add them together and I'll find 30.01 grams per 1 mole is the molar mass of nitrogen monoxide. I'll put 1 mole on the top and 30.01 grams on the bottom because I'm trying to make grams cancel. I now have moles of nitrogen monoxide. I'm then going to multiply this by something that will help me convert from the nitrogen monoxide into H2O. To find that value, I look to my balanced chemical equation. And I can see that we have 4 nitrogen monoxides produced every time 6 H2Os are produced. And so, since I want NO to cancel here, I'm going to put the 6 H2Os on the top, and I'll put the 4 NOs on the bottom, just taking that from here and here, respectively. I'll cancel out my nitrogen oxide there. Now I have moles of H2O, but I'm looking for grams of H2O. Luckily, we know how to convert between grams and moles. We need the molar mass. The molar mass for water is 1.008 times 2. That's the molar mass of hydrogen. And then we need, for the oxygen, it's 16. I'll add those two values together to get us 18.02 grams per 1 mole. Here I want to put the moles on bottom so that it will cancel with the moles in the numerator over there. 18.02 grams over 1 mole. Moles cancels with moles. And now I get to solve. Plug this all into the calculator. I'm writing it as 89.10 divided by 30.01 times 6 divided by 4 times 18.02. And you can enter this all as one continuous string into your calculator. Multiplication and division have the same priority, so it doesn't matter how you set it up, you'll get the right answer no matter what. And I have found that we should have 80.25 grams of H2O. And let's check that work. Great. Okay. Well, I hope you all found this instructive. If you have any questions, please feel free to shoot me an email, or heck, you can even leave it in a comment in the video below. Thank you so much for watching. Have a great rest of your day.